Hello, welcome to my presentation, Azure Stack HCI, the latest tips and tricks from the field. My name is Carsten. I'm a Microsoft Cloud and Data Center Management MVP and Azure MVP. I'm also a VM Vanguard and organizer of the Cloud and Data Center Conference Germany that takes place for the fifth time in March 2020 in Hanau. I'm the co-founder of the German Hyper-V community and hybrid cloud community. I tweet a bit on the Hyper-V server, and I'm one of the Hyper-V amigos. You find the Hyper-V Amigo showcasts under hyper-v-amigos.net. And if I'm not doing community work, I'm the CEO of Rachel IT Solutions, a German-based SI who implements storage spaces direct, Hyper-V and Hyper-V clusters, and a bit Azure Stack. And I blog under hyper-v-server.de. So why I'm giving this webinar? Because I've done with my company more than 200 storage spaces direct implementation in the fields, and we see a lot of things at customers. And we are also called, when we don't do this implementation, customer asks us for help because they have some trouble with different things. And the most trouble we see in networking. And networking is rather important for a storage spaces direct installation because we need a reliable, fast, low latency network between the S2D nodes. If you imagine a VM is writing data on one node on the disk, this data has to be copied to other hosts, and for that, the East-West network, I call it East-West network, SMB network is used. And also you can use it for live migration, for the cluster traffic, for the heartbeat. So we really need a reliable network here. And in our implementation, we do RDMA, RDMA SMB direct, unless we don't have a reliable network. We don't find a reliable network at a customer, then we maybe turn RDMA off and do SMB3 over TCP/IP. And that's a better choice than a flaky RDMA network to turn off RDMA, for example, especially if you do Rocky or Rocky V2 implementations. But I come to that after I talk a little bit about IWAP. So nowadays we have two kinds of RDMA versions we can choose over Ethernet. There's a fourth version. It's InfiniBand, but storage spaces direct, aka Azure Stack HCI, doesn't support InfiniBand, so we can choose IWAP over Ethernet or Rocky over Ethernet. IWAP is a network cards that have a processor. Let's call it processor. On the card, and this processor does the IWAP protocol, and the IWAP protocol is wrapped into TCP and then in IP, and the packets are put on the Ethernet. So this has the advantage, because IWAP uses TCP, that if a packet is dropped by the switches, the cards recognize that because of the TCP/IP window frame, and the sending card can resend the packet. And so we can use cheap switches or switches that are not enterprise switches, that don't offer PFC, ETS capabilities. It's also useful if you have IWAP that you can leverage PFC, especially if you use higher bandwidth like 50 or 100 gigabit IWAP, then PFC comes in handy, but it's not a requirement. If packets are dropped, IWAP, the NICs will resend the packets. An IWAP card still does RDMA to the host, so the IWAP card gets all the data from the memory without leveraging the CPU. So that's the advantage of RDMA. We don't burn CPU cycles on our host when we do fast network. This is done by a card. So the cards are more expensive than the Rocky cards. So let's come to Rocky. Rocky is available in two flavors, Rocky and Rocky V2. And nowadays you should use Rocky V2. When Rocky was invented by, I think, Mellanox. Mellanox is a company who is famous for InfiniBand. They have a lot of InfiniBand know-how. And to tell you the truth, these IB transport and IB network, IB is InfiniBand. So Rocky is in essence InfiniBand in Ethernet. And there is no other layer around it. So we put an InfiniBand protocol that is lossless, or at least when packets are lost, they will be resended by the protocol into an Ethernet frame. And Ethernet is lost. Ethernet packets can be lost. The switches are allowed, if they have congestions at the port, to throw away packets. And this doesn't really fit in lossless protocol in a lost full protocol. So we need the support of the switches with priority flow control, for example, to get our traffic lossless. And if you look here, we don't have IP involved here, so Rocky is not routable. We can't route Rocky traffic from one subnet to another. And there is a TCP/IP connection involved for the control information for SMB3. So we have IP addresses, and their connection will be initiated over IP addresses. But in Rocky, we have to have them in one subnet. So to mitigate this disadvantage, Rocky V2 was invented, and here we see the InfiniBand is now packet put into a UDP packet and then an IP packet and then on Ethernet. But UDP is still not lossless, or we don't know if a UDP packet is going missing like it is with TCP. So why on earth does the Rocky consortium, why they didn't choose TCP like IWAP does it? And the reason for that, as far as I know, is that TCP is when you go to fast bandwidth, so higher bandwidth like 100 gigabit, 200 gigabit, and Mellanox has already 200 gigabit per port. It's not reliable. TCP/IP has its problems there, and in fact, the IWAP consortium is also thinking about going to UDP for faster bandwidth. So we have UDP, so we have still to configure our switches. We need the support of the switches to get a lossless connection. And to mitigate the disadvantage over the IWAP implementation, because it's in TCP, Mellanox is working on the zero-touch configuration, where they claim that you don't have to configure the switches anymore because the network cards will recognize when packets go missing and they will resend them. That's promising, but we have to find out if it works because it's very new and it's only a Mellanox feature. Okay, Microsoft today recommends IWAP because they have a lot of support calls with wrong configured networks with Rocky. That's okay for me. You can do either IWAP or Rocky. We will look at the vendors soon, which provide network cards, but I still prefer Mellanox. That's partially because I've done it a long time with Mellanox. I know how to configure the switches, but I get the feeling that Mellanox Rocky is still a bit faster than IWAP. So coming to the vendors, you have different IWAP vendors. There's Chelsea. Chelsea does it for a long time. I think for years, maybe 5 years, there are Chelsea cards up to 100 gigabit. Problem in Germany, the OEMs, the vendors, Dell, Fujitsu, Lenovo, HPE, Data On, you name it, they don't have relationships with Chelsea. So it's hard to get a Chelsea card in your server, to buy it with a server so that you have your 5-year warranty from your OEM. But they are not bad, but you don't get them very good here. Then we have Marvel. Marvel was named Cavium, and before that QLogic. So The QLogic card works well with iWarp. I have those. We have them in many customer implementations. They work very well. And the OEMs have long-standing relationships with QLogic. They sold their fiber channel cards and their network cards, so you can get an implementation from those vendors with those cards, and you get the warranty. And then there's Intel. Intel, as far as I know, has invented iWarp in the good old days where Intel did good network stuff. In the moment, then there was a long time where Intel didn't have a network card that could iWarp, supported iWarp. Now they have a 10 gigabit card that does it. It's only available as a LOM, so you have it in your servers connected to the motherboard. It's the X722, but to be honest, I don't like this card. We have seen a lot of trouble with this card, and just go to the internet and look in the forums with the X722. There is a lot of people who have trouble with this card. Intel announced a new chip, the Ethernet 800 series, for the second half of this year, and it should support iWarp. It should go up to 100 gigabit per port, and it should support Rocky V2. Now, that's weird for Intel, because if you go to the website, you see a lot of marketing for iWarp, why it's a superior protocol over Rocky, and now they bring a chip that can do both. Okay. On the Mellanox, on the Rocky and Rocky V2 side, we have Mellanox as a vendor. They are there forever because of their InfiniBand knowledge. Then there was Emulex. They had an implementation where they supported Rocky V1, but it is not flawless. It has its problems, and Emulex revoked the production support for this card. So if you have those cards in your servers, turn off RDMA, because RDMA is turned on by default. And if you have it on this card, you do RDMA, you do Rocky, but the vendor who is not existing anymore because they were bought by Avagio, they also bought Broadcom, and they are now called Broadcom. They are not developing this chip anymore, and you don't get driver for 2016 and 2019, so you shouldn't have those cards in your servers, at least not for your east-west traffic. They are sold still, but don't use the RDMA support, turn it off. Then there is the Cisco VIC. I had my problems with this card, so Cisco and RDMA is not, in my opinion, not working well as far as I know, but you can turn off RDMA with this card, and that works well. Then we have Marvel again. They also do Rocky and Rocky V2, and also something important. If you buy a Marvel card for iWarp, the card is by default configured for Rocky V2. So not buy it, put it in your server, configure an IP address, and say, I'm golden because I don't have to configure PFC in my switches and so on. It is configured for Rocky V2. So you have to configure it for iWarp, and as far as I know, that's only possible in the BIOS of the card. So don't just get it, use it, and think you have iWarp, you then have Rocky V2. And then there is Broadcom. They are quite new with a new chip, and I have those cards up to 100 gigabit. I have four one-port 100 gigabit cards and 2-node S2D deployment. They seem to be reliable, but the performance is by far not as good as the Mellanox cards, and maybe they will fix that with new firmware. So next network tip is which switch to use, and there is today only one answer. It is the SET switch, and with Windows Server 2016, Microsoft introduced the SET switch. SET stands for Switch Embedded Teaming, and before that, and also still available today, is the classic Hyper-V switch, but you have to be aware that the classic Hyper-V switch is not developed anymore. It's feature complete. So all the good new stuff, all the improvements were programmed into the SET switch. And To be quite honest, when the SAT switch came out in 2016 with Windows Server 2016, Microsoft said use the SAT switch, not the classic switch, but we avoided it because a new part of software, a big part of software, this switch does teaming. This switch has the capability of guest RDMA. So you can create virtual NICs. You see it here. We have virtual NICs here that are NICs that are visible in the management OS. So in the Windows server where you have your Hyper-V installed, and you can use them with RDMA. That's great. So, but it was a lot of new software, and new software tends to have bugs. So we avoided the SAT switch in 2016 and 2017. And as far as I see it, it was good to not use it because there were still some bugs in there. And a lot of my peer MVPs had really trouble with the SAT switch. Nowadays, it's a completely different story. Most of the bugs were found, and it's very reliable. And nowadays, we go really with the SAT switch, and we leverage the advantages of the SAT switch. The classic switch, if you want to have high availability, as you have it here with the SAT switch, we have two network cards. They should be connected to different switches. If you want to do that with the classic switch, you have to use a team, the LBFO team, the built-in teaming module from Microsoft. And this is also not developed anymore. So you have software that is as it is. Yeah. The a disadvantage of the SAT switch, to be honest, is we only have one teaming let's call it protocol teaming mode. It only supports switch independent teaming. So you don't configure anything on your switches. These are two independent ports on the two switches. They don't know that they are in a bound or so. It's not an LACP. It's not a static team or so. You don't configure. You do configure anything there. Nothing is done there. And a lot of network people prefer LACP from the good old days. Microsoft and other virtualization vendors are convinced that there are no advantages when you look at Hyper-V switch, virtual switch, to use LACP. All the vendors prefer to use switch independent. And so the virtual switch, the SAT switch, only supports switch independent, not LACP. So if your networkers insist on LACP, you can only use the LBFO team, the old one, and the classic switch, and you don't see all the improvements like RDMA in the management OS, guest RDMA even in virtual machines. You can have that with 2019 in the SAT switch. DVMMQ, dynamic virtual multi-machine queues, and receiver-side coalescing. All great features that give you really performance in your VMs, up to over 50 gigabit in one VM you can do with a Hyper-V switch. And I think there are not many other hypervisors, if any, that really can do such bandwidth in a VM. When you use your when you set up this fully converged design, so let's say we have only two network cards in our Azure Stack HCI host with an SAT switch, you have to create VNICs or VNICs for your management OS because your cluster has to communicate with the domain. You have to have east-west communication between the nodes. So you have to generate at least a management adapter and two SMB adapters as virtual NICs. And if you do two SMB adapters because you want to have traffic over both networks that leverages SMB multi-channel, you should use two SMB subnets. And then you should bind the virtual RDMA adapters, let's call it virtual RDMA adapter 1 and 2, to one of those network adapters. So the virtual RDMA adapter 1 to this, the left adapter, and the virtual RDMA adapter 2 to the right adapter. Otherwise, the switch will decide which way the packet will go. The virtual RDMA adapter 1 the traffic could go over this adapter or this adapter. And That's not good for your switches, because then let's say the other Azure Stack HCI host is connected to both the two switches we have here, and if the packet goes here, it has to cross from one switch to another switch and then go to the host. And so we have a lot of traffic between the switches, and we don't want that. So bind the adapter to a physical NIC. All the physical NICs, the left ones should be in the same switch, and then the traffic will not leave the switch when we communicate with another host, and we don't have much congestion. If you have this fully converged design, you should think about protecting your cluster traffic, because if you do a live migration and you choose to use live migration over SMB3, that's great, because SMB3 can leverage RDMA, and you can move a virtual machine over both adapters. If these are 25 gigabit adapters, you can move a virtual machine over 50 gigabit to another host. Now we have a problem. The cluster traffic has maybe problems because the packets can't go through if the live migration is there. So you should protect your cluster traffic with a PFC class, and so configure that on the host and on the switches that your cluster traffic goes through. So what are typical mistakes or problems we see in the network design out in the wild? First is customers have one SMB subnet, because this was best practice from Microsoft in 2016, and then you have a lot of traffic between the switches. You still have two switches, you still have two adapters, and you have a lot of traffic between the switches, and there is a good chance that you have a lot of congestions, and that isn't the best design. So if you have your east-west traffic not over separate storage switches, you have everything connected to your core switches, and then you have one SMB subnet, for example, a lot of traffic is going between your core switches, and that can really disrupt or cause heavy problems in your network, because other network is dropped. Live migration can leverage the whole network, for example. You don't use the SCT switch because you had problems with it, and you went to the standard switch, or we also were huge opponents of the SCT switch in the early days, but you lose all the enhancement and the new features you won't get with the old switch. And your networkers want LACP and not switch independent, and you can't convince them to use switch independent, so you have to use the SCT switch, and you can't leverage the new possibilities in the SCT switch because LACP is not supported by the SCT switch, and as far as I guess, it will not be. I did a great webinar. Dan Kahumu did the webinar. I just introduced him and asked the questions people are asking in the chat. So I can strongly recommend this webinar. There was a lot of great stuff in there about the new possibilities with the SCT switch, and why not choose LACP and choose instead switch independent teaming. So my favorite network design is to separate the storage traffic, the RDMA traffic, with two separate ports with separate switches. So we have 4 RDMA capable network cards in the host. We use 2 of them for our VM traffic and our management traffic to connect to the core infrastructure. And we have 2 separate SMB adapters with separate switches if possible, and use them for our SMB traffic. Other improvements in an in storage-based direct or Azure Stack HCI. So in 2016, if you pull a disk because you think it's defect, you want to change it, you go there to the server, you pull a disk, put a new one in, nothing will happen. If you pull a disk, it has lost communication. It will be lost forever until you retire it manually. If it was not defect, then the system will retire it itself. So, but if the electronic is defect, it has lost communication, will not retire it. So you have to retire it as an administrator. In 2019, Microsoft changed that behavior. If one disk is missing for more than 15 minutes and only one disk, then it will be retired by the system. So that's great. If the electronic of the disk is defect, it has no write or read errors because it's gone. It will be retired automatically after 15 minutes. It's a huge improvement if you just want to swap out a disk. Another cool thing that is possible till 2016, you can have a switchless design for your east-west traffic. So for your storage traffic, for your live migration, for your cluster traffic. With 2 nodes, we have to have 4 NICs if we want redundancy. We have our SCT switch with the 2 blue NICs that are connected to the core infrastructure, 2 switches, and we have here 2 red NICs with RDMA possibilities, red NICs with RDMA capabilities, and we connect them directly to the second server with a direct attached cable without any switch. Of course, we have to configure here 2 SMB networks for our connections. Otherwise, if it would be 1 SMB network, this RDMA adapter cannot communicate with this one, and you will not get an error-free failover test, and it will not work properly. So this is possible from 2016 on, but now we can also do a 3-node switchless design, where we have also 4 NICs in every node. And we can connect our RDMA adapter here directly with the other hosts. But every node has to be connected to every other node. So we don't, Microsoft doesn't support, let's say, a circle with 4 nodes. Every node must be able to talk to the other nodes. So in this example, node 1 is connected to 2 and to 3, 2 is connected to 1 and to 3, and 3 is connected to 2 and 1. We have to use 3 SMB networks here, and then it will work. And this scenario is now supported by Microsoft. Other tips, let's go fast here. There is a bug in the 2-node 2019 design. If you shut down one node, let's say we shut down this node, then because there's a problem with the disk quorum, the virtual disks, the volumes go offline on this host, and all your virtual machines that are running here can't communicate with the storage system anymore, and they will crash or they will pause critical. And this is a known bug. And Microsoft is fixing it, and there are different fixes and different community updates. It should be fixed now in the September 2019 CU, but to get it on the system, you have some problems. You have to patch the system and reboot it, and then your workloads go offline. So you have 2 possibilities: shut down your workloads, so you have a downtime, or you enable the storage maintenance mode for the node that you reboot, and then it should not happen that your disks go online. And there is a nice script from Ben Thomas, a fellow MVP from Australia, where he has written a PowerShell function to help you with that. So, and my last thing is you should benchmark every Azure Stack HCI design really to find problems. We do that with every installation at customers, and even if a customer calls, we have some problems, we do benchmarking and we find a lot of problems in the network. Unfortunately, many people think Windows Explorer when we are talking about benchmarking. They are copying files from one node to another. And to be honest and frank, Explorer is not a good benchmarking tool because it does caching. And there is even a blog post from Microsoft where Microsoft says Explorer is not a good benchmarking tool. You should use disk speed for that. Disk speed is an open source disk performance measuring tool from Microsoft, and there is even VM Fleet a PowerShell tool set where you can measure your Azure Stack HCI design. And I personally also like IO-Meter, but I know Microsoft doesn't like it very much. It's an old tool from 2007, but I like it a lot. And here I have a video of for node cluster. You see here the cluster is doing nearly 1 million 8K IOPS. There are 120 VM fleet VMs doing 1 million 8K IOPS. I always do a write workload, so we have 30% write, 70% read. And while these 120 machines are doing the VM fleet test, we have another machine where IO-Meter is installed. It does 20,000 8K IOPS, full random, 50% read, 50% write. And here we have a mirror accelerated parity volume where you see the data is moved from the performance tier to the capacity tier. We have write, we see a lot of writes here. So you should do that all the time. And this is really the beauty of an Azure Stack HCI design, the performance you have. So if you want to have more information, I do regularly webinars in German and in English. And here's the link to my webinar archive. Just sign in here with your email address and your name, and you get immediate access to over 20 webinars I have done. Here's a shout out for the Hyper-V Amigo showcast, where I have done a 2-hour showcast how to set up VM fleet and how to measure with it. And that was my presentation. I want to thank Dave and Crystal for doing this great MVP days, and thank you for being in my presentation.